Hello friends, welcome to my channel Eccentric Learning. I hope you have gone through the first two parts of triangles where we have seen what are triangles and its properties, different types of triangles, and two very important theorems, Apollonius theorem and angular bisector theorem. In case if you haven't gone through those videos till now, the link has been given in the description box. Please go through it. Also, if you like my videos, then do subscribe my channel and also share with your friends. In this video, we are going to see the geometric centers of triangles like circumcenter, orthocentre, centroid, and so on. So let us begin with today's video. First, let us see what is the circumcenter of a triangle. Suppose if we have a triangle ABC with three sides AB, BC, and CA. Say we are drawing three perpendicular bisectors on each of these three sides BC, CA, and AB of triangle ABC. Perpendicular bisector is a line which bisects any side perpendicularly. Say if this line is the perpendicular bisector on the side BC at point DC, then the length BD would be equal to DC and this angle would be 90 degrees. In a similar way, if we draw a perpendicular bisector on the side AC at point EC, then the length AE would be equal to the length EC. And this angle would be 90 degrees. In a similar way, if we draw a perpendicular bisector on the side AB at point FC, then the length AF would be equal to the length BF. And this angle would be equal to 90 degrees. Now, all these perpendicular bisectors meet at a point which is called as circumcenter of the triangle, which we generally denote by capital S. So, circumcenter of a triangle is the meeting point of three perpendicular bisectors. Now, this circumcenter S is equidistant from all the three vertices A, B, and C of the triangle ABC. That is, the length SA is equal to the length SB is equal to the length SC. And this length is known as circumradius of the triangle, which we generally denote by capital R. Now, if we consider this circumcenter as the center of a circle and this circumradius as the radius of that circle, and if we draw the circle, then that circle would be passing through all these three vertices of the triangle, and this circle is known as circumcircle of the triangle. So, for a triangle, all the three perpendicular bisectors meet at a point which is known as circumcenter of the triangle, and this circumcenter is equidistant from all the three vertices of the triangle, and this length is known as circumradius of the triangle. And if we consider this circumcenter as the center of a circle and this circumradius as the radius of that circle, and if we draw a circle, then this circle would be passing through all the three vertices of the triangle, and this circle is known as circumcircle of the triangle. Now, there are some important points about the circumcenter of a triangle which we need to remember. For an acute angle triangle, the circumcenter would be lying inside the triangle. For a right angle triangle, the circumcenter would be lying on the hypotenuse of the triangle. And since the circumcenter is equidistant from the three vertices of the triangle, so for a right angle triangle, the circumcenter would be the midpoint of the hypotenuse. And for an obtuse angle triangle, the circumcenter would be lying outside the triangle. Also, there is a relation between the area of a triangle and the circumradius of the triangle, which is given by area of a triangle as A into B into C upon 4 into circumradius, where small a, small b, and small c are the length of the sides opposite to angle A, angle B, and angle C respectively. So, if we know the area of a triangle and the length of the three sides of a triangle, we can find the circumradius of the triangle simply by using this relation. Now, let us see what is incenter and excenter of a triangle. Say we have a triangle ABC with three angles, angle A, angle B, and angle C. Say we have drawn the internal bisector for angle A, the internal bisector for angle B, and the internal bisector for angle C. Now, all these internal bisectors will meet at a point, and this point is called as the incenter of the triangle, which we generally denote by capital I. This incenter is equidistant from all the three sides of the triangle. That is, if we draw perpendicular from this incenter on the three sides of the triangle, then all this perpendicular length would be C. Here, I have drawn three perpendiculars from this incenter on the three sides of the triangle. So, all these three perpendicular length would be same, and this length is known as Inradius of the triangle, which we generally denote by small r. Now, if we take this incenter as the center of a circle and this inradius as the radius of that circle, and if we draw the circle, then this circle would be touching all the three sides of the triangle on the inside. And this circle is known as incircle of the triangle. So, all the internal bisectors of a triangle meet at a point which is known as incenter of the triangle, and this incenter is equidistant from all the three sides of the triangle, and this perpendicular distance from each of these three sides is known as inradius of the triangle. And if we consider the incenter as the center and this inradius as the radius of a circle, and if we draw that circle, then we would be getting a circle which would be touching all the three sides of the triangle on the inside, and this circle is known as incircle of the triangle. Now, this angle BIC can be written in terms of this angle A, simply by using the angle sum property, that is, sum of the three angles of a triangle is 180 degree. Since these are the internal bisectors, let us assume this angle to be X and X, Y and Y, and Z and Z. So this 2x plus 2y plus 2z would be 180. So from here we can write x plus y plus z is 90 degree. In a similar way, if we consider the triangle BIC, we can say angle BIC plus y plus z will also be equal to 180 degree. Now, from these two relations, we can write angle BIC to be equal to 90 plus x. And this angle x is half of angle A, so angle BIC would be equal to 90 plus half of angle A. In a similar way, we can write angle CIA to be equal to 90 plus half of angle B, and angle AIB to be equal to 90 plus half of angle C. Well, we don't have to know this derivation. We can simply remember this relation, which would be helpful to find some unknown angles related to incenter of a triangle. Now, just like we have a relation between the area of a triangle and the circumradius, we also have a relation between the area of a triangle and the inradius, which is given by area of a triangle as S into R, where S is the semi-perimeter, that is half of the sum of the length of the three sides of the triangle. That is half of A plus B plus C, where small a, small b, and small c are the length of the three sides of the triangle corresponding to angle A, angle B, and angle C respectively. So, if we know the area of a triangle and the length of the three sides of a triangle, then we can find its inradius simply by using this relation. Now, let us see what is an excenter of a triangle. Excenter of a triangle is defined as the meeting point of one internal bisector and two external bisectors of a triangle. For example, Here, I have drawn the internal bisector of angle A and the external bisector of angle B and the external bisector of angle C. All these three bisectors meet at this point, and this point is called as the excenter of the triangle. In a similar way, if we consider the internal bisector of angle B and the external bisector of angle A and the external bisector of angle C, we'd be getting another excenter somewhere here. And in a similar way, if we consider the internal bisector of angle C and the external bisectors of angle A and angle B, then we'd be getting another excenter somewhere here. So there will be totally 3 excenters for the triangle, one corresponding to the internal bisector of each angle. So incenter is the meeting point of 3 internal bisectors of the triangle, and excenter is the meeting point of 1 internal bisector and 2 external bisectors of the triangle. Now let us see what is an orthocenter of a triangle. Suppose if we have a triangle ABC such that from the vertex A, one perpendicular AD is drawn on the side BC. From the vertex B, the perpendicular BE is drawn on the side AC, and from the vertex C, one perpendicular CF is drawn on the side AB. Then these 3 altitudes or perpendiculars meet at a point, and this point is called as the orthocenter of the triangle, which we generally denote by capital O. So orthocenter is the meeting point of 3 altitudes of a triangle. Here also angle BOC, angle AOC and angle AOB can be written in terms of angle A, angle B and angle C respectively, and is given by angle BOC as 180 minus angle A, angle COA as 180 minus angle B, and angle AOB as 180 minus angle C. Well, if you are interested, you can also derive this relation simply by using the angle sum property. But my suggestion would be to simply remember this relation, which would be sufficient. Just like in the case of circumcenter, we also need to remember some of the important points in case of orthocenter as well. For an acute angle triangle, orthocenter would be lying inside the triangle. For a right angle triangle, orthocenter would be the vertex where the right angle is formed. That is, the vertex which would be opposite to the hypotenuse would be the orthocenter in case of a right angle triangle. And in case of an obtuse angle triangle, orthocenter would be lying outside the triangle. So these are some important points which we need to remember in case of an orthocenter of a triangle, which is the meeting point of 3 perpendiculars. Now let us see what is a centroid of a triangle. Suppose if you have a triangle ABC such that AD is the median on the side BC, then D would be the midpoint of the side BC. So the length of BD and DC would be equal. In a similar way, if we draw a median BE on the side AC, then E would be the midpoint of the side AC. So the length of AE and EC would be equal. In a similar way, if we draw a median CF on the side AB, then F would be the midpoint of the side AB. So the length of AF and BF would be equal. Now all these 3 medians meet at a point, and this point is called as the centroid of the triangle, which we generally denote by capital G. So centroid is the meeting point of all the 3 medians of a triangle. Now there are some properties of the medians and centroid of a triangle which we need to remember. The first is centroid divides each of the median of the triangle in the ratio 2:1. That is, AG is to GD is equal to BG is to GE is equal to CG is to GF equal to 2:1. That is, AG and GD ratio is 2:1, or BG is to GE ratio is 2:1, or CG is to GF ratio is 2:1. Since AG is to GD is 2:1, so AG can be written as 2/3 of the median length AD, and GD can be written as 1/3 of the median length AD. In a similar way, BG can be written as 2/3 of BE, and GE can be written as 1/3 of BE. And CG can be written as 2/3 of CF, and GF can be written as 1/3 of CF. Also, a median of a triangle will divide the triangle into two equal halves. In this triangle ABC, AD is a median, so the area of triangle ABD and the area of triangle ADC would be equal. We can prove this simply by knowing that area of a triangle is given by half into base into altitude. Since for the triangle ABD and triangle ADC, AD is the median, so D is the midpoint, so the length of BD and DC are equal, that is, the basis length are equal. And also, these two triangles will have the same altitude, so the area of these two triangles would be equal. In a similar way, since BE is the median, so the area of triangle BEC and the area of triangle ABE would be equal. And since CF is the median, so the area of triangle AFC and the area of triangle BFC will also be equal. So any median of a triangle will divide the triangle into two equal halves. Also, when the three medians of a triangle are drawn, the resulting 6 triangles are equal in area, and the area of each of these triangles is equal to 1/6 of the area of the original triangle. So for this triangle ABC, the resulting 6 triangles are AGF, BGF, BGD, GDC, EGC, and AGE. So the area of all these triangles are equal, and the area of each of these triangles is equal to 1/6 of the area of the original triangle ABC. So centroid of a triangle will divide each of the median in the ratio 2:1. Any median of a triangle will divide the triangle into two equal halves, and the resulting 6 triangles formed by 3 medians of a triangle will be equal in area, and the area of each of these triangles is equal to 1/6 of the area of the original triangle. Now let us consider a right angle triangle ABC right angle at B. Say BD is a median drawn from this right angle on the hypotenuse AC. Since BD is the median, so D would be the midpoint of the hypotenuse AC. So the length of AD and the length of CD would be equal. We know for a right angle triangle, the circumcenter lies on the hypotenuse of the triangle and is the midpoint of the hypotenuse of the triangle. So the point D would be the circumcenter for this right angle triangle ABC. And AD and CD would be the circumradius of this triangle ABC. So now if we draw the circumcircle would be something like this, where D is the center and DA, DC and DB are the circumradius for this triangle ABC. So the length of the median BD would be equal to AD or DC. And since AD or DC is the circumradius of the triangle ABC, so the length of the median BD will also be equal to the circumradius. Since D is the midpoint of the hypotenuse AC, so AD would be equal to DC, which would be equal to half of AC. So BD, that is the length of the median, can also be written as half of the length of the hypotenuse, and this is equal to the circumradius capital R. So in a right angle triangle, the length of the median drawn to the hypotenuse is equal to half the hypotenuse and is also the circumradius of the right angle triangle. So, to summarize, in a triangle, the circumcenter is the meeting point of the three perpendicular bisectors of the triangle. The incenter is the meeting point of the internal bisectors of the three angles of the triangle. Orthocentre is the meeting point of the three perpendiculars of the triangle, and the centroid is the meeting point of the three medians of the triangle. Let us remember these two important points as well. In an isosceles triangle, the centroid, orthocentre, incenter, and circumcenter all lie on the median to the base. And in case of an equilateral triangle, the centroid, orthocentre, incenter, and circumcenter all coincide. That is, all the points centroid, orthocentre, incenter, and circumcenter will be same in case of an equilateral triangle. So that's it for today's video, in which we have seen the geometric centers of triangle like circumcenter, orthocentre, centroid, and so on. And in the next video, we are going to see the area of triangle in various forms and some special triangles like 30, 60, 90 degree triangle, 45, 45, 90 degree triangle, and so on. I hope you have learned something in today's video, but if you have any confusion, you can watch the video again, and still if you have any doubts, you can put it in the comment box. I will try to answer each one of your queries. So if you like my videos, then do subscribe my channel and also share with your friends. I will see you all in my next video. Till then, keep learning, keep sharing, and keep growing. Thank you.